So, okay, guys, so it's gonna be like in English because my Catalan is not so good, Spanish as well, French as well, but I can do it in German if you like, but I guess no one understands German. I've got a question, like how many are developers here? And how many are like engineers, architects or something, that DevOps engineers? Okay, so kind of mixed. Because I'm wondering, I have the same presentation, but there is a light version and there is more deep dive version, like for engineers. What do you want to see, like the lighter version or more deep dive? For the high level, yeah. Okay, because I don't know, like, let's see. Okay, good. So basically, what I'm going to talk about is about Cloud Code. So I'm coding like since a year, not anymore with, I'm not writing code anymore, so I'm just using Cloud Code all the time. And many of you also probably use the same, like, I don't know, who's writing code manually still, like touch some codes, or everyone is doing like, okay, crazy. That's interesting because like usually in the last few months, the coding became so good that it's almost not needed to write anything anymore. But anyway, so what I did is actually I did an experiment. I was thinking, how can I build like applications without, driving Cloud Code, kind of like not babysitting, like when you write application, you need to babysit, you need to tell, do this, do that, and whatever. And I was kind of like lazy to do that. So I was thinking, how can I do that? So, and then I was sitting like kind of at my home and I was thinking like, how is it possible to code that I don't need to manage the process? So Cloud Code is doing completely everything for me, from like design perspective till QA engineering till like, even deployments. And like many of you might remember, there was this crypto hype, blockchain hype, like, I don't know, 5 years ago, whatever. And I was reading a book from this guy who wrote Ethereum. He was describing like how Ethereum algorithm works, like how every how their blockchain works and how they make sure that the transactions on the blockchain cannot be faked. And there was one important thing that I was reading. I remember this thing. It's called Byzantine algorithm. Do you know, like, any of you know what Byzantine algorithm is, how it works? No? This is actually a pretty easy thing, because like mostly this is coming from plane like flights and whatever, like in the plane industry. Like if a plane flies, usually if a plane like goes down, this is a human error. It's not a technical error, usually it's a human error. So in the planes, there are like, for example, there is some kind of like algorithm or some kind of functionality. If it goes dark, it's not working anymore. There are secondary backup system, but there's not only one backup system. There are usually 3 to 4 backup systems for a single functionality in the plane. And that's how actually blockchain works in terms of Ethereum. They use this Byzantine algorithm that is basically checking a transaction from 3 different or 4 different angles to understand if this transaction is real or not. And I was thinking, okay, this is amazing because we can use the same approach basically to check if, let's say, AI agent writes the codes, then I just take another 3 AI agents to check if this code is valid, right? It's like a kind of logical step. So, but it was not logical for me because like I was always checking it myself and it was kind of like pain in the ass to get everything working. And basically what I then did is that I created this process. It contains of 10 steps basically, and it's working. Like I wrote almost more than 150 features already with it, and it's functional. So basically there is a file, it's called roadmap file, where you define like all your features of the project. It has all the features, like, I don't know, 200, 300 features. And then basically you take a system like Cloud Code, it goes through the roadmap, picks something to build. It tells me, hey, I want to build this feature. Are you agree with that? Yes, go and build this feature. Then it does research. It writes all the specs automatically. And then there is a step, this step here, the 3C, it's spec consensus review. Basically what it does, it takes like 3 different agents from different models. So I'm using Cloud Code Codex, using Minimax and GLM 5.1 now. Basically it takes different models, reviews the codes, and then it tells me, hey, this is good, you can go ahead, you can write this, or this is bad, go back and iterate. And then all the implementation happens here. So I'm just gonna be showing each step a bit faster, because like there are 10 steps, it's actually a lot to explain, but I will stop for some kind of super interesting steps here. So basically, what is important, if you write anything with Cloud Code or Codex, there are skills. Do you know what skills are? So it's kind of basic markdown files. And I created like 4 different skills. The first one is the orchestrator. I just tell, hey, feature ship. Then it goes into the roadmap, checks what is the next feature to build. Then it tells me, hey, like let's say we are building a refund system. Okay, I agree. Then there is another skill, it's called spec. It writes the specs, which means it takes this feature, analyzes the whole code base, writes exactly the specs in a markdown file. It's not writing the code, it's just writing the specs. But the specs are like, when you take the markdown file, you see like really it's writing how the code would look like. It's not the real code, but it's how it should look like. And then once this one finished, it goes into this review phase. Then there is a ship build thing that actually is building the codes. And then there is the last one, which is like QA, doing all the QA automatically. It's doing both verification on the browser and doing also verification on the backend. And the interesting part that I discovered when I was building this is that usually AI systems or models, when you take like a model that is a complex one, it takes a lot of time to understand anything. So Cloud has 2 models. One is like called Haiku. This is the cheapest model. It's like super fast. In Codex, there is this how it's called Spark. Spark, it's also extremely fast. So what I do here, I take the code that was written, and all the QA happens in the following way that I take a cheap model that is extremely fast. It goes and checks everything, does the screenshotting, does all the things about the system, what was built. And then I take another system, which is like Opus. I take for this one Opus it was like most of the time it was 4.6. And Opus goes and checks like, actually, is this correct or not? So basically, you can mix and match different models. One model is super fast, it's just doing all the screenshotting or whatever, and another model is doing the real check. And this is actually how it works. So this is like the whole thing here. And basically how it starts, it creates a work tree. And then in the work tree, I will skip this step, it's not important. Just working with work trees because you cannot branch out from the Git. The problem is that you cannot work on multiple branches. And usually the whole thing here, all these 10 steps, they run in parallel. So which means that I start like multiple sessions and they run all in parallel, like almost 4 to 5 sessions, because usually it takes like up to 4 hours to build a feature. It's not like building a feature within like 10 minutes or 1 hour. It's taking a lot of time to build a feature because out of review steps, it's going back and forth. And I can tell you it's working. This is crazy. I mean, the only thing that is maybe not so perfect is this design step. But in general, everything is working perfectly. And what about this? Yeah. Hello. Okay, it's better. About this, so why this process actually exists, the problem that I thought I had is basically I had to do a lot of manual QA, and I was kind of like bored about this, so I just built this 10-step process, There's nothing specific about that. And I'm not using special tools or plugins or whatever people are telling, like some people have like 10 different MCPs installed. I don't use that. So there is only one MCP installed. It's called DevTools MCP. That is basically starting my Chrome and is doing all this stuff in the Chrome, and it's nothing more. So it's the process is super lean. But there is another thing that I discovered actually, which is super interesting, and maybe this is important also for you as well, is that when you have a tool, let's say you have Clouds or Codex that build the functionality, and then you need third-party models to review your work or to review the work of the Clouds or Codex. And many people use like API endpoints from OpenRouter, different models, just to send this information. And I try to do that as well. But the problem is if you use actually API calls, those API calls, you cannot send files there. So basically the point is that you cannot send any files. I mean, you can get the content of this and send to the API endpoints. But in a sense, it makes no sense, because like if you build a feature, it has probably like on average like 20 files that has been created with different, information in there. And what you can do is actually you can hack clouds and use it with different models. So one big cloud orchestrator spins up another cloud with a cloud code, CLI, with a different model. And this CLI does all the scanning of the files. It does, checking all the work, what has been done. It basically like kind of a secondary model that runs, but I'm not using the same model because I want to get feedback from other models as well. So those Chinese models are super cool, and they're like super cheap actually to work with. And yeah, there is a model selection part, which is a bit, it's not complex, but usually when you work with Cloud Code and you build 4 to 5 features in parallel, it takes 4 to 5 hours. You run out of your limits. So there are no limits anymore. And I use this max subscription that costs $200 per month. If you go to the API, it's going to be costing me probably like thousands of dollars. I don't want to spend that money. But the problem is when you start building stuff, you will see how fast you get to the limits when you use this approach. Like if you do it like single player modes yourself, you'll not get to the limits. But if you do it multiplayer mode, like here in this approach, it basically takes like all of your tokens like within a couple of hours. You're just left without limits. And then when I was hitting all the time the limit constraint, then I was like switching basically the models by itself. So I knew, for example, Minimax. Do you know what this model does, or have you used that, Minimax or GLM5? It's basically like Chinese cheap model, but Minimax is good because like when you buy a plan that's around $80, it's super fast. You get 100 tokens per second, I think. I'm not sure exactly, but it's super fast. GLM5 is also amazing, but it's super slow. It's like sometimes it's not available, sometimes it's crashing, sometimes it's just not delivering anything. So you need to swap the models so you don't overspend when you build stuff. Because like, I don't know, I think that more or less all that stuff is gonna super expensive. Already for me, it's getting super expensive. Like when you have like 3 to 4 subscriptions, it's around like $700 per month, which is not cheap. But okay, let's go through the steps here. If you have any questions, just interrupt me anyway. So I've got the roadmap file. This roadmap file has all the features written down for the whole project. And this is important. If you want to build something that builds stuff automatically, you need to plan a lot. So I spent maybe weeks, literally, it was not like 1 week, it was multiple weeks planning out the features, because you cannot just throw shit at it and say, okay, build it. It's not going to work like this. You need to really plan this out. And the product roadmap is like a checklist. It's a huge checklist. It's just showing, okay, what was built, what's going to be next. And then there is a second step. It's actually this one. It's write the research document under docs feature and then the name of the research document. And this step is important because it creates the scope of the feature. So any AI agent can go back, picks the scope, read how was it built. Okay, I understand the context and understand what to do here. And once the specs are written, then this consensus review starts. And basically the consensus review is like 3 different models that review each other. And how it works, so to make it short, so you're not super bored here. So how it works, basically, there is the main model, which I'm using usually, like the strongest model from cloud is Opus, is taking the research, what it has written, how the feature has to build, and it creates a review prompt. So basically it says, okay, look, this is the research, this is what you want to, this is what we want to build, the features are outlined exactly. And then it basically spins up like 3 cloud instances. So, and this Minimax instance is basically cloud codes, CLI, but it runs a different model. You can just configure a different model. Then there is a Sonnet. I'm using Sonnet because it is cheaper and a bit faster, because if you do all the time anything with open Opus, it's gonna be like costing a lot. And then there is a GLM model, which is taking also the input. And basically what they do, they just check everything what was written. So they check everything what was written, and then they merge the verdicts and bring it back to the main model. And the main model decides, can I go to the next step, or should I stop now? And this is this Byzantine algorithm that actually is behind all these things. And usually there are like multiple rounds. So the first round is usually like Minimax says, okay, you need to rework the plan. Sonnet says you need to rework the plan. GLM says you need to rework the plan. But the good thing is that if you give 3 models the same inputs and you get the same output, then each model says, okay, this feature or this request that you want to do is wrong. It's basically 3 models tell to the main model like what needs to be corrected, which is amazing, because like you cannot take one model and review, because this model might hallucinate, it might not understand everything. Here it says Minimax, Sonnet, and GLM. They say, okay, this is thing you need to rework. Then it reworks and it does the same work again. It creates a review prompt. It drops this new information to each model, and then it waits. It takes a lot of time, actually. That's why it takes to build a feature 4 hours, because this process actually takes on average like 10 minutes. So they just run in the background. It takes a lot of time. You need to wait. Then it comes back. Then they need to rework. Like if the models say this something is broken, then they need to rework again. Then it goes again. And I have a rule that 3 reviews are done automatically, which means there's no my involvement needed. The models operate by themselves. If they come back and say, look, it's not working, no one of this, they need to agree, by the way. These guys need to agree. So they give information back. Maybe it's here somewhere written. So it's visible. Just a second. Yeah, okay, I forgot this to add this. But they need to agree. So if in the Byzantine mods, out of 3 reviewers, 2 needs to agree. This is important. Like if only 1 agrees, this model says, okay, this is cool, you can go ahead. But Sonnet and GLM tells, no, it's not good. Then there is the next round, until they fix each other and agree. If they don't agree the 3rd time, then the model stops and tells me, hey, you have to decide yourself, because we don't agree on the process. And this is actually the main brain of the whole thing. I mean, everything around is pretty understandable, it's pretty easy, but this thing is super important in the sense that once they agree, you can be sure everything is gonna work out of the box immediately. Yeah.
The agreement model is so each model should say agree, go on with the exact plan, or if there are some adjustments, some comments, some things, they go also in the loop to review the original plan.
Exactly. So yeah, they go back.
What if the feedback is different from each of the 3? Not a throwback, but maybe some adjustment, but different adjustments. It goes always in the loop until all the 3 agree.
Until 2 agree. So in the Byzantine consensus, there must be 2 reviewers that agree. It's kind of like if, let's say, the pilot flies the plane, and there is something wrong on the panel, and they can check 2-3 tools in the sense that, is this correct or is it just like broken? So the same approach is here. So they go after each other and check like agree until they agree. So usually
Is it a loop or loopy?
3 loops. Yeah, 3. I mean, you can run more loops if you like, but the problem is that you will be out of your tokens like after, I don't know, 5-6 loops. So if you do that, because they cannot stop, they just go and go and go. You need to interrupt. And the point is that all these things are happening in a Tmax session, which means I don't see this even. It's happening, in the background process. I don't know what's going on there. I just wait, sit, and say, hey, status, what's your status? It says, okay, we are ready. Or what's your status? It's like, somewhere in the background, I just forget about this. You've got a question? Yeah.
Yeah, good question. So at the times you gotta jump in to kind of, or if they do not agree, right? From your experience, what have you found the most useful kind of output at that given time? Is it the different rationales of each of the models, or it's the reasoning why they do not agree, or how do you iterate that kind of output just to see?
Yeah. So basically, they don't. So basically, when they stop, they don't agree about small things. It's actually everything is correct, and then they tell, hey, there is a small thing that no one agrees about. You need to decide yourself. It's really like stupid small things that are not even words to analyze, but they are strict. They cannot just go and just bypass. That's why they sometimes stop. But usually after 3 rounds, I would say 90% of the agents, they go through the next step. They don't interrupt. So it's 1 out of 10. There's an interruption. They ask myself, what should I do?
In those cases, do you kind of base the hard? Well, I don't know if you use hardness analysis. Do you, let's say, do you update the hardness based on if this kind of, I don't know, if you do not agree in this kind of situation slash, I don't know, right, an issue, let's use this rationale. So next time you either have to ask me, or you prefer to get kind of a jump in, or
I prefer not to jump in because like I'm too lazy. To be honest, like when I was working on that and building this out, I was like building out each step, and I had to course correct each step. And I realized that after 3 steps, this agreement is always, let's say, out of 10 agents, most of them agree. And there's something small, really, like they might just stop without, they say, there is a CSS that is not correct or something, you know, some stupid things where it's like, okay, just go ahead, don't bother me with it, you know. And this is the point. But when I had, you need to have like this hard gates. So if you don't have these hard gates, they will just do crazy stuff. They will just do, you know, they won't follow the commands. They will just like, one agree, two disagree. It just will go ahead. You just will tell stop, you know. And that's why sometimes you need to interfere, but most of the time it's like something very small. You've got a question? No? Yeah, so basically this is the heart of the thing. The hardest thing to solve was actually is that first of all, to get good models to run. By the way, it's not that, you know, easy to get some good models that have a subscription. You know, I don't want to like pay API fees from some third-party models. And Minimax has a great subscription. It's like $80, and GLM has $30 subscription. It works. And Sonnet, I mean, Sonnet is included in my subscription anyway. But the biggest problem was that when you run this consensus is that the models might time out. So basically the review part might take up to 10 minutes, even longer. And let's say like two models time out and only one comes back, the system is not able to go further. So you need to build exponential retries into the system that it checks the system, is this model still alive or not? If not, restart the process. And it's happening actually quite often that the models just time out, or the limits. For example, GLM has 2 concurrent limits, so which means you cannot run 5 agents in parallel. You have 2 agents that you can run in parallel. So for the best model, but there are cheaper models that have as well 2 concurrent limits. So I had to build slots that needs to be acquired. So let's say I have 4 agents in parallel. The first 2 agents acquire the best GLM model. The next 2 acquire the you know, the worst, not the worst, but then the next one on the list. So I had to manage this a lot. But at the end of the day, that's working perfect now. So I don't need to interrupt. I need to check this because it retries automatically. That's it. So yeah.
What about the context of each of the reviewers? Have they have different size of the context? Because maybe they can have the same window of context, and they can have different answers because if they see different things or have this or that.
So the main model, the orchestrator model, which is Opus, it has 1 million contexts, which is amazing. Those this one and this one, they have 200K context windows. And Sonnet has, I think it's 1 million as well. I'm not sure. But the point is that it is enough context to make a review, but it's not going to be enough context to build the whole feature. That's why 1 million context actually, I was thinking like, what's the point of 1 million context? You know, it's like a huge thing. Why do I need that? Usually you don't need that. But to be honest, like when you want to build a feature fully automatically with AI agents, you need 1 million context. 200K window is not enough for nothing. It's going to stop in the middle of the pipeline. It's just not going to work here. Yeah. Yes.
How you propose sensor gateway as P2P or mesh topology?
You mean the orchestrator? This is a basic model, the Opus model. It just sits there and waits for the feedback. It's just like in the background.
I don't know. Can you give me background on Opus model?
Opus model is this model from Cloud Code, which is like the best, one of the best models, let's say. I mean, it's not the best, it's kind of like nerfed model, whatever, but it's one of the best on the market. There is this Codex model, it's also very good from ChatGPT. And basically, the strong model like does the management of everything. And down the line, I use like cheaper models or models that are faster just to save tokens. Otherwise, I would not bother about this. I would just like use Opus everywhere as well. I don't care. But if they, like when you build 4 features in parallel, you can forget this. It's not gonna work. After 1 hour, you're out of limit,
Have you tried to improve the saving token, let's say, so to compress maybe the review, to compress text, to remove any text that is not me for the review, and just have
Not really. I'm going always the other way direction. I just dump everything. Yeah, just give everything. Just take everything what you can. Read all the files, until you just get crazy. Because once you start to optimize all the stuff, that's diminishing return. I did a lot. It's like, as a developer, you optimize the workflow. Then 6 months later, a new tool comes up. You need to re-optimize the workflow. Now I'm super lazy. I have a huge model. Okay, cool, 1 million. Let's jump. Let's do it and just work and see until it hits the limits and it's not working anymore. Then I need to optimize. But this part was actually the hardest one to do. But that's actually the most important one, because everything else is like super straightforward. There is nothing special. So basically, in the first 3 phases, to recap, because I was talking a lot about this, in the first 3 phases, the model picks a feature from the roadmap. It creates a document here. This is a research file. Then these 3 models recheck this research file if this is good or not. And already this process, these 3 steps that take about 1 hour, maybe 1 hour and a half. So it's taking a lot, actually. Here's the thing. So the reviewers inspect the same workstream and return approved or changes needed. That's what each reviewer is giving back. If it says approved, fine. If changes needed, it writes what needs to be changed. That's it. And then they change the stuff. Okay, and then once everything is done, then there is actually the boring stuff that is happening. It takes the research document and it writes tests for that. So I used TDD for that because, usually when I was coding manually, I really hated to write tests because I was thinking always this is waste of time, because you don't ship features. You need to make sure the features are working. But now I got superpower because AI can do that. So all the parts that I did not like, AI can take over. So it starts actually with test-driven development. Basically, it writes all the tests based on the research, because then it's pretty easy to cross-check what was written here. So it writes the tests, then it starts to implement the backend work. So in this project, I'm using Golang as a backend, which is amazing. And the front end is basic HTML data star. I'm not using any React or Next.js or whatever, all this all these frameworks, because they're not needed anymore. AI is pretty straightforward when writing front ends. It writes the backends, it writes the front ends, and then there is a smaller QA, which is basically the same model that has written everything. It just goes back and cross-checks, hey, what was written. It tries also to run build commands and all this stuff, linting or whatever, just to make sure everything's clean and we can go forwards. And here, basically, at this step here is step 6. It needs to restore the green state, basically, because here we write the tests, and it might write 100 tests or 50 tests or whatever. It writes a lot of tests. Then once everything was implemented, it needs to have the green state. This usual test-driven development. And now the funny part starts, basically. So what is important to understand is that you need to keep track where the model is, because you have these 10 steps, and each step the model might time out, my laptop sometimes it's just too hot. Seriously, it's just powering down and whatever. And you need always to keep track where it was left, because otherwise you need to restart all the stuff from the start. And there's a state, simple JSON file, and there's like QA handoff. It's basically each QA run is doing a handoff for the next stages. So the next stages understand what has been built, and then there is a result, and there is like some QA summary. Okay, this is, and now comes the funny part actually, because in this process here, so why it takes so long and why it takes so many tokens to build a single feature is that, look here, now probably this is more important, is that I have here a first consensus review on the step number 5, which cross-checks the docs. But then there is a verification part which is done by the agents, but there is another consensus review, which means it kicks the same review again after it has been built everything. So this is important part, because I was skipping this part and it was like not delivering. But once I built this another consensus review, it was like delivering amazing work. And basically how this verification stuff works here is straightforward. So there is the first step, it's called UI verification step. I spin up a cheap model, Haiku in a sense. Haiku is super fast. It's taking DevTools. It's spinning up my browsers, and it's doing all the manual verification. It's like clicking the buttons, doing, delete or add something, whatever was built. Sometimes this step is getting skipped if there's only backend work, some workers, whatever, there's no UI verification. But usually this is the important step, because this is what I was doing when I was like coding mostly with Cloud Code, because it's building, but something is not working and whatever. So Haiku is basically doing all the clicks and saving the screenshots. It's not analyzing what has built. It's saving the screenshot. It's saving all the information about the application itself. And then once it's ready, it goes. Opus, the strongest model, takes all the information, all the screenshots, all the output that was given by Haiku, and does the check. I mean, you don't check you use these cheap models just to do faster things, but you take the strongest models to verify if this is even correct or not, what has been built. And that was kind of, for me, one of the insights as well, when I was thinking, wow, this is crazy, because like people, usually when you open up the tool, you see there is like different models. Which model should I use for what? I was always using the strongest model, but then I realized that some models can be used for cheaper tasks, and the strongest models can be used for tasks that are important. Once it verifies everything is working in the UI, then there's another step which is also pretty cool. It's called UI polish. This step is the same. Haiku starts the browser, does the screenshotting of that, and Opus takes the screenshots and does the UI polishing. It's basically doing the design work as a designer. So it looks at the screenshot, it says, okay, the buttons are in the wrong color, or they are wrongly positioned, and whatever. It brings, the whole design, so it's looking good. I mean, it's not looking perfect, to be honest. Like, it's not like if some person would do that, but still it's amazing what it produces. And done, then it has this self-review part. Again, Opus checks again what has been built in this step, and only then I pass this to the second round of this consensus review. Why this? Because this consensus review takes a lot of time actually to get the answer back. So sometimes it is better to take a model to review the work before you give this for review. And what is important here is that each stage here, so this stage, phase 7 to phase 10, they start in a fresh context, which means they are not in the same session. They're just like in the background in a completely new session. They have no context about what has been built. They just get the inputs. This is the feature. I mean, they understand what has been built, but they don't know how it was built. This is important because they can then analyze how it was built and self-correct the whole thing. Yeah, actually, this is like the summary here. Opus QI Reasoner, then Haiku does the DevTools driver, Chrome's screenshots logs, and then Opus reads the result, fixes, and rechecks. And this is kind of amazing because, like, usually I was thinking that this is pretty hard to do something like this, but I can tell you this automation is amazing. So, I mean, and the best tool that I can recommend you, don't use like codecs or open codes. All these CLIs that are in the market, they are super bad in driving agents automatically. It's called autonomously, probably the right word for that. Cloud Code is the best tool for that. So you can use Cloud Code. It's amazing in driving everything, and I had never any issues with that. Sometimes when I have no limits on Cloud Code and I need to switch to codecs is just like stopping each step. They just stop. Something is not working, it's breaking, it's not working. It's just like very bad in driving agents. And this is like probably the strongest part of Cloud Code. So to summarize the whole thing, so the brain of the whole thing is this consensus review with different models. Then basically when you want to drive all the agents automatically, you should use Cloud Code. Don't use codecs, don't use open code, whatever. And yeah, make sure that you use cheap models for some kind of stupid things. Don't use like the expensive models for things that are needed. Like if something needs to click on the UI, just use the cheapest model and let another model review. And basically that's it. So this is kind of a summary of what is happening. And then the last step is here is a closeout and definition of done. So a feature is done only when the pipeline can prove closure. So it cannot like say I'm done. So it needs to prove all the steps were successful and they were built. This is important. So there's a checklist that is basically doing all this cross checks, but it's super fast. It's not very complex. Then the branch is then squashed. So it does every step, it does new commits, which means that I can go back if the system breaks. It can go back to a step and restart. This is an important step because if you don't do that, the models sometimes like freak out or a timeout or something is happening, then you need to restart that stuff. So I need to squash them, push, and then it creates a PR, and then it tells me, hey, I'm done, and that's it. And this is actually, maybe I can even show this. Like something that I was building. So for example, here it says it shipped. It usually means it passed all the steps. So, and it does the final commit with the feature, and it says autonomous implementation. The same here. So basically in this session I had some, just give me a second. So I had 4 agents in parallel running. Here you can see the amount of tokens per feature. It's like 500k tokens, so which means you cannot, take the cheap model and run it with 200k tokens. It's not gonna work out anyway. You need 1 million of tokens. You need 1 million token to do that properly. This is important. And then here. So what I write actually, so it's finished, correct? Yes, it says finished because it runs in the background. I don't see what it's doing actually. I just see like, hey, I'm done, or the next step, or there is a problem. This is what I see. So sometimes I need to ask the model. And sometimes also Cloud Code has, no, it's working. Okay, I was thinking it's not working. And sometimes the interesting part is what today was like, they had issues on the API, whatever, and they were like just blocking the model. It wasn't working. So if it's in the background, you don't know it's working or not. It just like tries, and it's working. So maybe I can. So this is like the output that I usually get here, QA complete, ready to merge. All right, you see it says pass, verification, UI polish, skip. It has picked no UI, backend worker, JSON API. So no need to do that, self-review. So here, for example, the consensus code review rounds 1, 2 changes needed, round 2 approved. So I get all this information. So it's not kind of like, it cannot just fake something. So it was important. It was faking information, but when you have hard gates, it cannot fake here. It's gonna be like doing the work. And then here, close roadmap marked, worked with crashed, pushed. So basically it marks also in the roadmap that this feature has been done because the next agent knows which feature to pick. Otherwise, you don't know which feature to pick out of all the features. Yeah. Here's another output, also a feature shipped, verdict. Here, for example, we see code review 2 out of 3 approved, Minimax plus Sonnet GLM need changes but non-blocking. So if the model decides it's not blocking, you just go ahead. It's not stopping on going back on doing some things, And you see here, it has written like 40 tests, for a single feature. And this has been done automatically. I was not asking for anything. It's just like doing all the work, and does all these things. And here it does also screenshots here on the artifacts. It does the screenshotting. I can go and see the screenshots. I don't fire up the app. I don't do it manually because you cannot do it. Like if you do, I know, 4 features in parallel, you just get crazy to look at everything. So then sometimes I take a look at the screenshot, what has the model has done, whatever. Otherwise, if this is working correctly, it's doing also small security audits, so it's not like completely crap what we ship. But in this case, the only thing that is needed to do once everything is finished is you need to go and to do some manual UI work, so UI adjustments. You need to do better designs because usually design is okay, it's working, but it's not looking very great. So yeah. Yep.
I have another question. Have you tried, perhaps not, but stacking developments? Like usually when you write you have a PR open, right, and you want to start branching off that one in particular because there are few things that you want to reuse and cherry picking the whole thing. Um, that's one question. So if you tried, right, we have feature A and feature B. Feature A is needed on feature B, so you kind of stack on top of the other PR. And if so, if you have if you had to deal with conflicts, if you had to iterate feature A and then how you handle that on feature B later on.
Yeah, that's one of the points. That's what I say in the beginning. You need to plan a lot. So yeah, I was planning maybe a couple of weeks. I don't know, maybe 1 or 2 weeks, and maybe longer. I can't remember. So basically, I'm using a like Golang, and I'm using feature slice architecture. Probably you heard of that, because feature slice is amazing here. So you can build feature independent, and they just have interfaces for each other. So they don't know about each other. So you need to have the proper architecture. Otherwise, it's not gonna work. I mean, if you have like an application that is kind of like, just vibe coded, whatever, it's not gonna work. It's just gonna break after like 4 or 5 runs. Everything will be like breaking. Here everything is independent. They don't know each other. And what I do actually, once they're finished, now they're finished, so the next step, I would go and take one instance of cloud, and I would say, oh, look, there are 4 PRs open, you need to create a merge plan. So it goes and analyzes what is open, it creates a merge plan, and it shows me, okay, there are 2 merge conflicts, there's 1 merge conflict, how would we want to deal with it? And basically it knows how to deal with it actually. But you need to encapsulate everything, otherwise it's not going to work. Everything is encapsulated, every component, every feature, even CSS is encapsulated as well. Yeah.
So, going back to the hard gates configuration, I have this problem when I work with top, that I'm not sure about how is pondering the rules, what goes on top of the other rules, or sometimes after a few prompts, like forgot, some important skill that I explicitly asked to use in some performance. So how do you say, okay, this hard gate, you need to respect this, and how you make sure that this is working in the
Yeah, I know what you mean. I know what you're talking about. So when you have a skill, it's actually everything is based on skills, and the skill, when you define all the gates, it's respecting the gates. So if you put these gates into a cloud MD, or I don't know, in the context, it's not going to respect. It's going to forget after like 2 interaction. You need to put this in the skill itself. Yeah.
What about using prior write with Hikey for testing web order? Is better than use.
You can use Playwright if you want. The point why I'm using DevTools, because it's now native in Chrome, so it's kind of faster, easier. It takes less context, because usually Haiku has 200k limit window as well. So Playwright might take half of the context, just for information, context, whatever. But DevTools is super fast. And usually when I use Playwright, I use this for real automated tests, written tests. In this case, by the way, is actually, when we go back, okay, it's not working. It's sorry, it's Linux, guys. Sometimes it's not working, but but the point is that there are no front-end tests written here. It's only backend unit tests, regression tests for the backend. The amazing thing that I always hated is you need to write component tests for the front end, but the models now they understand the context. So if Heiko gets spin up with DevTools, it knows that it needs to click this button to log in with these credentials to use this or that information from the screen. So basically, the amazing thing is that you don't need to write tests anymore for that, for the UI, because it understands what's going on in the UI, you know?
How do you handle parallel execution and parallel testing in the UI side? They spin up different instances.
Yeah, they spin up isolated instances. Usually,
Share database.
yeah, this is everything here. So it's basically they create a new database, they apply the migrations, they do everything parallel, and sometimes they close my Chrome. So like if I'm in a meeting, they just close everything. This happens as well because the models are fully autonomous. Sometimes they just go crazy and close the Chrome browsers. But usually when you work, you see something is popping up. Okay, it's gonna like something from the background is doing the UI verification. And sometimes if I'm like, I don't know, tired in the evening, I'm just look what is actually doing this thing, you know, because it's fascinating. It's like some stupid thing is doing something, like it's clicking on the UI. It's like, what's going on here? I can still believe that this is like, you know, true, but yeah. So that's why my machine crashes a lot, actually, because when you, I mean, this is Golang backend is pretty easy to run, but I also do a lot of Next.js development. It's like 3 to 4 Next.js servers. You can forget it's like flying, you know, from a table. It's like, it's like okay, and then just like shut down after 10 minutes because it's getting too high, too hot. And this is another thing, actually, what many people don't, you know, underestimate is that how much loads can you run in parallel in your machine. So, okay, if you have like strong MacBook with, I don't know, 64 gig and MX5 Pro, then it's fine. But if you have like a normal ThinkPad, you can forget this. I mean, it's just not gonna work. Your machine is gonna like shut down every 30 minutes, which is crazy because I was never thinking about this. It's like another, you know, limit that you have. You don't have only the limit on the machine itself, on the API itself. You have a limit on your machine. It's just like physically not capable to run more than like 5 to 6 agents. Yeah. All right.